Hello and welcome to the Advent of Code 2021, day 7. Today we are giving a list of positions of crabs, and what we are asked to do for the part 1 is to find a position in a position that minimizes the total distance between that position and all the crabs. So for example, in this case, in this small list, we have a list of position of crabs, and for position 2 we see that we have to move 14 steps the first crab, 1 step the second crab, no steps 0 because it's already in position 2 the second crab, the crab number 3 in this case, and so on. We take the sum of all the distances and we found how much it would cost to move all the crabs to position 2. What we're asked to do is to find a position that minimizes the total movement of the crabs. So let's see. Here we have the scaffolding as usual. The input is in this form. It's just a list of positions separated by comma, and positions are all positive integers. So first I read the file. I read the file and I split by comma as usual, and I already convert to an integer. This is just the usual beginning of every problem. Then I pass this list of integers to part 1. So how do we solve it? I would say that we have to simply calculate the total distance of every crab from every possible position. So let's start by creating the list of all the possible positions. So we call it positions, and it's a list that initially will be 0 because we still have to calculate the content. And this list has a length, which is the maximum of the crab's position. Why the maximum? Because we know that every position after the last crab is only getting worse, because we're just getting more distant from every possible crab, so we are not getting any advantage. So we know for sure that the solution is before the last crab. Now what we do is simply we go through the crabs. So for every crab position, I'm being explicit here in crabs, what I do, I want to say, okay, for every crab for which I know the position, I want to go through all the possible positions that are in the solution and increase them of the distance between that position and the crab we are considering. So essentially a double for that iterates over all the combination between crabs and position. So here I say that for pos in positions, pos in range of len positions, because I care about the index, not about the position itself, but where it is. Or even better, for pos, actually it's fine. So for every position, and notice that pos here is the index of the position, so let's call it pos idx. So for every index of a position, which is the where a possible solution is, I say that positions, which is the solution of the problem at that position, pos idx, is increased by what? By the distance between that position and the crab I'm considering now. But the distance is always positive. So instead of just saying crab position minus pos idx, which could be negative, I put all of this in an abs function. So I take the absolute value. And inside this is already a position, because the position index is the position itself in the way we represent the problem. So we can just say pos. Okay, that's it. And now we have an array of positions. Once this cycle is done, for every position in here, we have the sum of the distances from all crabs. The problem is asking us to find the position that minimizes the sum of all the distances. So what we do is we find the mean distance, which will be mean of positions. This is the minimum distance. The problem is asking us where this is. Is it correct? Ah no, actually it's asking us already what is the minimum. So this is already the result. So I can just return it. And let's run it. It's giving error because it's trying also to run part 2. This is the solution for my case, so it's just this number. I insert it here, and that's the solution. Let's see briefly if we can do a bit better. So this is already working, and it worked fine. A thing that worries me a bit as a developer is to observe that there is this double for cycle. This means that the computer may spend quite some time in processing this stuff, because if we have 1000 positions and they are in a range of 0 to 1000, we'll have 1 million comparisons. Can we do better? Yes. For example, we can observe that if we go from the left to the right, every time we move to a cell, we have to increase the sum of distances of the number of crepes we found so far. So we do not have actually to consider crepes separately with a for, but we can actually move through the crepe positions and every time increase the counter. So let's do this in a well, I'm not going to do that, but I probably do that in my nicer version of the code that you can find on GitHub. So you can see it there, and see you for part 2.